Okay, we're about to dive into something really fascinating. What if our most advanced, cutting-edge technology isn't actually inventing something new, but is instead rediscovering truths we've known for thousands of years? So let's get into it.
Have you ever had that feeling, that sense of déjà vu, where the future we're all racing to build feels somehow like a reflection of something that's already deep inside of us? That's the core question we're exploring today.
So here's what we're doing. We're going to connect three worlds that, at first glance, seem like they have nothing to do with each other. The absolute bleeding edge of artificial intelligence, the incredible biological computer inside our own skulls, and, you won't believe it, the profound insights of ancient wisdom.
Right, so let's start with the machine itself. For decades now, there's been this one fundamental problem that's held computing back, almost like a permanent traffic jam built right into the system. Okay, so what you're seeing here really gets to the heart of that problem. Traditional computers are constantly, and I mean constantly, shuttling data back and forth between their memory, the RAM, and their processor, the CPU. It's just a massive bottleneck. But these new neuromorphic chips, they're inspired by the brain. They integrate the memory and the processing together, and that traffic jam, it just vanishes. And look, this isn't just some theory on a whiteboard. This is happening right now. We're seeing this revolution in the real world. You've got Intel's Low-He 3, which is a chip with millions of artificial neurons, and IBM's North Pole architecture is scaling up for production. This hardware shift is real, and it's happening fast. So, what's the payoff for all this? Well, for certain kinds of jobs, like real-time sensory processing or robotics, these new chips can be up to 100 times more efficient than the super powerful GPUs we use today. That is just a mind-blowing leap in performance. So how on earth do they pull this off? Well, the secret is actually beautifully simple. Unlike a normal chip that's always on, always burning power, these chips only use energy when there's new information to deal with. They only fire when they're needed. Sound familiar? That's exactly how the neurons in your brain work. Which brings us to the original blueprint for all of this, doesn't it? This brand new hardware is inspired by something much older and way, way more efficient. Let's talk about the original supercomputer, the one you're carrying around with you right now. This number right here is it's incredible. Your brain, with all of its power to learn, to dream, to create, to feel, runs on about 20 watts of power. Think about that. That's the same as a dim little light bulb. It has no separate RAM, it can learn from just one example, and its efficiency is something our best engineers can still only dream about. And here's where it gets really interesting. Computers, they think in rigid ones and zeros, on or off. But the brain is so much more sophisticated. It uses these analog spikes where the timing and the intensity of the signal carry the real information. It's a much richer, more nuanced language. And we're actually getting closer to speaking that language. Brain-computer interface wearables are becoming a real thing. You've got Neurables headsets that can actually track your focus in real time, or Emotivs earbuds that can read your brainwaves to tell if you're stressed or in a flow state. We're starting to build a bridge, right, to actually harmonize with our own biology. Okay, so we've seen AI mimicking the brain. But this is where the story takes a really wild turn. What if the brain's very architecture, its fundamental operating principles, were already mapped out thousands of years ago? Not in a science textbook, but in philosophy. Let's start with this core concept from Buddhist philosophy called anatta, which translates to no self. It says that the mind isn't a single, fixed thing. There's no little CEO sitting in a command chair in your head. Instead, it's a distributed, interdependent system of processes. There is no central you. And then there's the second key principle, pratitya samutpada, or dependent origination. This is the idea that nothing exists by itself in a vacuum. Everything, and I mean everything, arises in dependence on other factors. Every neuron, every thought, every single action is just one part of this vast interconnected web. So let's just recap. A distributed system, no central boss, where everything arises in relation to everything else. Does that ring any bells for you? Because what I just described, that's not just ancient philosophy. That is a perfect description of how a modern artificial neural network actually works. There's no central command. Each little node's output is completely dependent on the inputs it gets from thousands of others. The intelligence just emerges from the whole interconnected system.
And this connection, it's not just some cool coincidence people noticed. It's so powerful that it's inspiring whole new fields of research. You have academics right now who are actively exploring things like dharmic intelligence, and they're using these ancient principles to build new frameworks for AI ethics, trying to bake ideas like interdependence and non-harm right into the code from the very beginning.
So, we've connected the dots between brand new hardware, our own incredible brains, and this timeless philosophy. But, okay, let's take a breath here. It's really important to stay grounded and look at the bigger picture.
Now, I can already hear what some of you might be thinking, and yeah, these are totally fair questions. Silicon isn't the same as biological wetware. An AI can be programmed to simulate empathy, sure, but it can't feel compassion. And of course, exploring our inner world doesn't mean we should just stop exploring the cosmos.
See, the real point here, the real value, isn't about finding some magic bullet or a final answer to everything. The value is in using this incredible convergence, this mapping of biology, hardware, and wisdom, to start asking much better, much deeper, and way more interesting questions about the nature of consciousness itself. And all of this leads to a really powerful and kind of humbling idea. We spend so much time and energy trying to build the next great machine. But what if the ultimate technology, the most advanced computer in the known universe, isn't something we need to build at all? What if it's the one we're already using to think that very thought? And that leaves us with one final question to just chew on. We've always defined progress by these giant leaps outward, to the moon, to Mars, to the stars. But what if the most important, the most transformative leap that humanity still has to take is the one inward?